Welcome to the Getting Started with UDEC7 training session. This session will be divided into three parts. We'll start with an overview of UDEC. Then we will walk through a relatively simple tutorial of using UDEC and building a model interactively. And then we will perform the same modeling exercise using only commands. All of the material, including the example files and a walkthrough for how to do this, is provided as downloads. So to start with, what is UDEC? Originally, many years ago, UDEC was written as a two-dimensional discrete element program. And what this means is that we have an assembly of rigid blocks, and these are any convex polygon that can interact at their points of contact. But the blocks themselves are not deformable. So this is a purely discontinuous system, but it does allow you to perform some modeling exercises like shown here, where you might have an assembly of blocks interacting with each other and showing some sort of slope failure or something like that. Later on, the blocks themselves were made deformable. And this was done by actually zoning the blocks. So each individual block is like a small continuum model. And this means that stresses and strains and displacements can be calculated within each block. And the blocks themselves can actually deform and fail plastically depending on what constitutive model you assign to them. So you can see the bottom plot here is we have some blocks denoted by the thick black lines that have been divided into zones denoted by the gray lines. And you can see how the blocks themselves are deformable, as well as there being interaction at the interfaces between the blocks. So the modern day UDEC is more accurately described as a hybrid continuum-discontinuum program. So just to show you where UDEC lands on the spectrum of software offerings from ITASCA, you can see on the left here is the more traditional continuum approach for solving problems, where you have some sort of grid, and then you may have a small number of fractures or interfaces dividing up this grid. In the middle, we have UDEC and its 3D version, 3DEC. And so what you can see is this assembly of blocks that can interact with each other at the points of contact, but the blocks themselves can also deform. And on the right-hand side, you have the pure discontinuum approach, which is PFC, where you have particles interacting with each other at the points of contact, but the particles are not themselves deformable. So just a little bit about how you go about using UDEC. UDEC and 3DEC, the 3D version, and in fact, all of the ITASCA programs are command-driven. And what this means is that anything you do related to building models and doing calculations are the result of a command, which can be typed in or more commonly read from a data file. So commands can be stored in data files, and this is actually useful for keeping track of things, doing quality analysis, definitely for doing batch runs or parameter studies, and also enables you to do scripting so that you can change things sort of dynamically. All the commands take the form noun, verb, option, modifiers, range. So we'll show a bit more about this later, but you can see an example here. You start with the thing that you're operating on, the block, and then you're going to do something to that block. So in this case, you're going to group it, and then you give a name of that group, and then you give a range, and this is usually some spatial range over which the command is acting. There are some graphical tools that assist with model building, and we'll show that in the tutorial. But under the hood, these are actually issuing commands that can be, again, stored in a data file. All of the plotting and interpretation, so once you've built the model and done the calculation and you want to plot things, all of that is actually fully interactive and mouse-driven, although you can, in theory, use commands for doing the plotting as well. Okay, so actually using the program, there are two different interfaces provided with UDEC version 7. There's the older interface, which we call GEEC, Graphical Interface for ITASCA Codes. And then there's the newer interface, which we'll just call GUI, Graphical User Interface. The GEEC is older technology. It's been around for many versions of UDEC. And it allows for interactive model creation. So you use your mouse to click on things and build up models and assign properties and so on. And again, as mentioned before, it's actually emitting commands under the hood. The GUI is a newer interface. The plotting is much nicer. There's a lot more capabilities when it comes to interpretation and visualization. But we haven't yet got all of the model building capabilities in there. So we still provide you with both flavors of UDEC interface. And I'm going to walk through both of them when we do the tutorial later. So just so you can see how it looks, when you install UDEC, there's actually two different menu items in Windows. You can see on the right-hand side here. If you just choose UDEC7, you get the modern-day GUI interface. And if you choose the UDEC7 GEEC, you get the older interactive interface. And so you can, both of those are installed when you install the program, and you just have to choose which one you actually want to use. Here's just another view of the modern day GUI and the text editor. And so just a couple of notes before we move on to the tutorial. There are some new features in version 7, for example, discrete fracture networks, geometries that are not part of the old-fashioned GEEC. So if you want to use these new features, you have to use the newer GUI. I should also note here that, like I said, the GEEC produces data files, and the GUI also produces data files. These are exactly the same. You can run a data file from the GEEC in the GUI, and you can run a data file from the GUI in the GEEC. Similarly, the save files, if you save a model in one, you can open it in the other. The only thing that is not interchangeable is the actually project files, and this is sort of the container of all of your data and save states, and I'll talk a little bit more about that later. So that's the end of part one. We're now going to go and use the GEEC to build a model of sliding blocks as shown here.